Hello and welcome to the next lesson of Cambridge International IGCSE Physics, and today we are looking at power and energy. And by the end of this lesson I want you to calculate electrical energy and power and also calculate the cost of electricity. So this here is a picture of a fan heater that I used to own a long time ago, and it's got a lot of words on here, the make, model, etc. But it's the bit I'm interested in. It says 2000 W. What does that mean? Well, most of you probably know it means 2000 watts, but what does 2000 watts mean? Well, it means 2000 joules of energy are used every second. So it's telling me how much electrical energy it's transferring every second. So it's 2000. Or you might see it written as 2 kW, which is also 2000 watts. So again, this one here has got 60 watts written on. So it's using 60 joules of energy every second. How many joules of energy are used after 2 seconds? So that would be 120. After 3 seconds, it will be 180, etc., etc. So from that, we can get a definition of power. Power is the amount of energy transferred in a given time. 1 watt means 1 joule of energy transferred every second. So power is energy divided by time, or rearrange that, and we get energy as power times time. Energy in joules, power in watts, and time in seconds. Be careful of the time bit. Quite often it will give you it in other units and you will need to convert. So if they give you it in minutes or hours, you need to divide by 60, or if it's an hour, 3,600, because there are 3,600 seconds in an hour. So an example question: what was the power rating of a PlayStation 4 given it uses 700 joules of energy in 5 seconds? So energy is 700 joules, time is 5 seconds, power is energy over time, 700 over 5 is 140 watts. Another question: how much energy is used by a 40-watt bulb when it's left on for 1 minute? So the key is this time you need to convert the minutes to seconds. So 1 minute is 60 seconds. Energy is power times time. 40 times 60 is 2,400 joules. Okay. Here are some questions for you to have a go at. Pause it, and I'll put the answer on in a few seconds. And here come the answers. Okay. So calculate the power of an electrical appliance from the current and potential difference. So that's another way you might be. So what we looked at previously is very similar to the energy and power we looked at when we looked at the first unit when we were talking about efficiency and things like that. Now we are looking focusing on the electrical power. So formula for you that you may or may not have seen before. Power is current times voltage. P for power, V for voltage, and we use letter I for current. P equals IV. Like I say, voltage measured in volts, current measured in amperes, which we abbreviate to amps, and power measured in watts. In Malaysia, standard mains electricity is 240 volts, or 230 to 240, depending on where you look. For the 60 and 100 watt bulbs, calculate the current flowing. So 60 watts, current is power over voltage, 6 over 240, 0.25 amps. For the 100-watt bulb, power over voltage, so it's still the same voltage, but we've got a different power rating, so 0.42 amps. Okay, have a go at these questions now. I'll pause it, or rather you should pause it, and then I'll put the answer on in a few seconds. Okay, so let's have a look at a few more formula now that we need. So far we said power is energy over time. We've also said power is current times voltage. Therefore, we can say energy divided by time is current times voltage. We can then take the time across to the other side and we get energy as current times time times voltage, I, T, and V. And if you live in the UK, equals ITV. You may recognize that as channel 3. If not, you will not get that reference. We also need to know, sorry, that work done is QV. Energy is charge times voltage. So Q is charge measured in coulombs. V is voltage measured in volts. Again, a couple of questions for you to have a go at. Okay, and another set of questions for you to have a go at. I'll pause it and I'll put the answers on straight away. Okay, here's the answers. And that is the first learning objective complete. Calculate electrical energy and power. Now, the second learning objective is about the cost of electricity. Now, when you were younger, or if you maybe even still now, did your parents or do your parents ever moan at you for leaving the lights on when you go to bed? I know my parents were quite bad for it when I was younger. They were always complaining about how much money it would cost. So let's actually have a look at how much money it does cost to leave a light bulb on overnight. So if you ever look at an electricity bill, you will see how many units you've used. Sometimes it might be written as units, sometimes it might be written as a kilowatt hour, kWh. Now, this is one of the few times where we actually use hours instead of seconds as for electrical bills. So the number of kilowatt hours equals power times time. Now, this time, like I say, you need to have the time in hours, which is a little bit unusual. So power is measured in kilowatts, time in hours. Cost of electricity is number of kilowatt hours times the cost per kilowatt hour or the cost per unit, depending on where you look. So back to the bulb overnight. Let's say your bulb is left on for 8 hours. That's how long you go to sleep for. The average price for electricity in Malaysia is about 45 cents per unit, or was when I checked a couple of months ago. An average living room will be powered by a 100-watt bulb. It does vary a little bit, but that's about average. Number of kilowatt hours is power times time. So 0.1, because you've got to convert 100 watts to kilowatts, or that's 0.1 kilowatts, times 8 hours, which is 0.8 kilowatt hours. Times that by 45 cents, and you get total price of about 36 cents to leave a light bulb on overnight. So next time your parents complain about it, flick them 50 cents and tell them to keep the change, and hopefully they won't be too angry if we're being a little bit cheeky with them. So have a go at these questions here. The price of electricity is 12p per kilowatt. So this is a UK example. How much does it cost for each of these things? And I'll put the answer. By the way, 12p is similar to 12 cents in Malaysia, or depending on where you are, it's like 0.12 pounds. But we'll call it pence for now. I think I'll put these on here. Oops. Okay, so here is an electrical bill. This is what an electrical bill might look like. So sometimes you get different prices for day and night times. It's usually a bit cheaper at night time because they're trying to encourage people to use more electricity at night and less during the day. So this here is a typical bill. So starting in June 2025, and that was the reading on the electrical meter for the daytime in June 2025. This was the same reading in August 2025, and this is the cost per unit or kilowatt hour. So you can see the number of units used was 25447 minus how much it was at the start of June. So how much it had already been paid for, 24806. So that was a difference of 641 units. So the total cost for the daytime is 384.6 ringgit. Have a go at the nighttime to see if you can also get the total cost. I'll put the answer on in a few seconds. Okay, so this is a quarterly bill, something that's maybe not used too commonly anymore, so every 3 months, of 688 ringgit and 10 cents for the electricity for 3 months. And this here is a past paper IGCSE paper 2 question. So a 2 kilowatt heater is connected to a mains power supply. Cost of electricity is $0.3 per kilowatt hour. What is the total cost of using the heater for 15 minutes? So 15 minutes is quarter of an hour, so 0.25 hours. So it's number of kilowatt hours used, first of all, is 2 times 0.25. So that is a half. Then it's a half times 30 cents, which gives you 15 cents. And that's it for today's lesson. Next lesson is on non-ohmic conductors, which I will be uploading soon. Thank you very much, everyone, and I see you later. Bye-bye.